So I'm working on a new process for machining the get off me tool number 6. Right now, this one here you're looking at is an ultralight. So that means that it's 1/8 of an inch thick, so that's 0.125 inches, rather than the typical 3/16 of an inch thick, which is 0.1875 inches. Now the significance of this is that when it comes off the mill, as you can see this end, at this point it can still be either a forward or reverse edge, or perhaps something else I might have in mind that I'll share with you at a fairly near date in the near future. So this was the small win I had today. I had everything programmed up, I had the fixture made, so I had a test fixture. Normally I would machine this into a pallet, but what I've started doing is machining a test fixture. And what that allows me to do is not kind of feel committed to a pallet, because a pallet costs a lot more than just a little chunk of aluminum or steel to put in a vise. So I'll do a vise-based fixture and just move it around here because this thing's trying to slide off the pillow. So yeah, it kind of keeps me feeling flexible to have just a test fixture, and then all the things that I learn when I run that, I make notes as I go, and I apply all those things to the actual pallet. So I use the Pearson work holding MPS, right? That's the smaller pallet system that they have, and that is very well suited to the Tormac. I'm running the PCNC 770 by Tormac, which is it's a little bit older model now. They've got some better stuff now with the 30 taper spindles and whatnot, but this works for our purposes. And as you can see there, there's no grips added yet. The jimping gets added in another process in the vise currently, just because it does a cleaner job, because I don't want to go bigger. Some guys go bigger on the jimping and then they run the end mill in there and interpolate the jimping, but I don't like doing that because the size of jimping that I like to use would require me to use like a smaller end mill, and I don't want to go there. So I just stack these in a special jaw that I make for the vise and rip across them with it's a carbide inserted center drill or spot drill. I shouldn't say center drill, it's not a center drill at all. It's a carbide inserted spot drill, and it's really good for chamfering. I do chamfer a lot of parts with it, and I do put a lot of jimping in with it. It's got it's approximately the same geometry at the tip as a 1/8 ball, right? So I could use one of those, but I find this carbide inserted thing is a lot more economical. So I just wanted to share a bit about this. Somebody's trying to call me right now. That kind of weirded me out. All of a sudden this thing flashes up on the screen. So that's what I've been up to today. So I'm doing a handful of these. The way it works out, these are A2 tool steel. So I buy in the 1/8 or the 3/16, and it's 2.5 inches wide. And I get 4 blanks out of that piece, and each blank produces 2 of these. So that's pretty handy. There's no waste, right? There's no little offcut at the end. That's just cut it in 4 evenly spaced pieces, and then there's just a couple little pieces that get cut out, like the center out of the ring, and then there's a little piece each side, and then there's a piece in the center. So if you watched my Instagram stories recently, you'll have seen what those pieces look like. So it's very economical, right? We don't like to waste material, and this job certainly allows for a good yield. So the other thing is this end piece here that gets cut off, but the piece on the end here, there's going to be like an angle or a wedge shape attached to it. And I call this piece, it's a sacrificial piece, I call it the bevel stabilizer. So when this goes on to the next process, where it's determined whether this is a forward or reverse edge or whatever else it might be, that piece gets cut off, and that piece serves to stabilize the bevel while it's being milled. And I have coined the term bevel stabilizer for that, and that works very well. And I've devised a fixture for this that allows me to run the same program whether this is a forward or reverse edge. It's just a matter of which way we put the part in the fixture. So that's pretty handy, right? I don't have to decide right away. Maybe I'm doing a bunch and then I get an order or a request, and I can just flip one around and make, specifically what that person has asked for. So it saves me on having, similar fixtures, right? Like I would have two fixtures, but in this case I have one because it works both ways. And there's a couple other things it's going to work for too that I haven't revealed yet. So I can't speak about that yet, but that's going to be pretty interesting. The other thing that's interesting about it is that fixture orients this part in such a way that the cutting edge is actually running parallel with the x-axis on the mill. So what that means is that rather than interpolating the bevel, it's actually just doing a straight x-axis cut. So that's going to improve surface finish. And, that's kind of like the ideal scenario, right? So it's just going to step down and over in the Z and Y, and then it's just going to cut across in the X. So I'm going to wrap that up at this point. Stand by. There's going to be some very interesting announcements soon.